So how can a normal distribution vary from one set of data to the next? There's basically two parameters that can change, that can cause us to get different normal distributions. So the first one is the mean. If you look at the moment, I've set the mean mu as being 2.5, and that can increase or decrease. So I've got lots of different values that obviously mu can take, and similarly the standard deviation can change. The standard deviation is how spread out the data is. So the greater this is, you can see the more spread out the data is going to be. I've still got a normal distribution here, it's just that it's spread out much further than if I reduce the standard deviation to, let's say, being 1, which means the data is much more tightly packed around the mean like that. Now, because of that, when we define our normal distribution, we write it using this notation on the right hand side here. We say x is distributed normally, and the two parameters we need to say is what the mean is and what the standard deviation is. Those are the two parameters that cause the normal distribution to be the shape and the position that it is. Now, the slight confusion here is actually the information that we give on the right hand side is the variance and not the normal distribution. And that's primarily because when we want to combine normal distributions, for example, it's easier for us to work with variances than it is for us to work with standard deviations. So whilst the input into your graphical calculator will be the standard deviation, technically it is meant to be the variance that we write here. And as a result, we often write it like this. To give an example down here, we can say, right, x is normally distributed with a mean of 5 and a standard deviation of 2. So technically we've still written the variance on the right hand side here as we're meant to, but by writing it as 2 squared, it means I can easily see, okay, the standard deviation is 2. I don't need to go about square rooting anything to get the value that I really need to be inputting into my graphical calculator. If I just go back to this, so let's just set this up. We're going to have a mean of 5 and a standard deviation of 2. So that's what this particular distribution looks like. And notice that what happened is as the standard deviation increased, the data got more spread out, but the height came down. And the reason for that is we have to maintain an area beneath this curve of 1. So if we make the normal distribution more spread out, it's got to come down to ensure that that area is maintained. So really what's being measured here on the y-axis is pretty meaningless to us. It's all about the area, that's what we're interested in from this distribution. So that's the distribution, and from that I can now calculate various probabilities. If, for example, I wanted to work out the probability that x is less than 6, let's go to this. I'll show the area now. So if I change the lower limit to being down to sort of negative infinity, around about there, and the upper limit as being 6, then that area there is going to calculate the probability that I want, which in this case is 0.69. How do we do that on our GDC then? Obviously we won't normally have this kind of an emulator. So the way that we type that in, if I bring up my GDC here, is I go into a calculator mode, menu, I then want to do probability, distributions, and I am going to be using normal CDF, the cumulative distribution function. I'll be asked for the lower limit. In this case that was negative infinity. So negative 9e999 means minus 9 times 10 to the 999, which is obviously a huge negative number, which we can treat as like it's negative infinity. And even if we change that to a smaller number, let's say negative 1,000, that would be perfectly adequate for our purposes. We then have in our question an upper limit of 6, so I'll type that in, and for us the mean, if we look back here, the mean was 5 and the standard deviation was 2, so I can type that in, press OK, and it just instantly calculates that probability for me, 0.691, which we can see to 2dp was the same as I had on my emulator here. I can then calculate other probabilities. So let's say, for example, I wanted to work out the probability that x is greater than 6. So probability that x is greater than 6 means that now my lower limit is going to be 6, and my upper limit will be positive infinity. So that's the sort of shading that I'll get from that. I can again type that into my calculator. And once you've done this once, you can, rather than going through the menus, you can just copy and paste the sort of the way that we've typed this in and change just the limits that we want. So I want the lower limit to be 6 and the upper limit to be positive infinity, because I'm going up to infinity. I'm just going to put in a really big number there, enter, and I get 0.309. And as we'd expect, there was a shortcut we could have done here, because the area that we're trying to find and the area that we tried to find out previously, those combined takes up the entirety of the area beneath this curve, which means we know that they add up together to give us 1. So we could have simply done 1 minus the answer that we'd previously calculated, and it would have given us the same probability. So using the ideas of area is really useful often when we're doing these sorts of questions. The last thing we might have is we might have a question, let's say like this, when we're trying to work out the probability between two values, so between 5 and 6. So again, if I have a look at what that looks like, lower limit now is going to be 5, upper limit is going to be 6, like this, and so 0.19 it's saying it's going to be. If I again go into my GDC, rather than going through the whole menus again, I will just change that to being a lower limit of 5 and upper limit of 6, and I can see I get the same value, 0.191 to 3 significant figures. Again, a little shortcut I could have done here is, in working out this area here, I already knew what the area was from 6 down to negative infinity, and because 5 is the mean, I know the probability of being less than 5 is going to be 0.5. So I could have taken my previous answer, this one here, and subtracted 0.5, and it would have given me exactly the same answer. So again, I can use my knowledge of areas to my advantage here.